Hello friends, so in this video I'm going to talk about a circuit breaker pattern here. Okay, so the circuit breaker pattern is a design pattern that used in microservices architectures to handle the potential failures gracefully and to improve the resilience of your system. Okay, so here what is the circuit breaker pattern? So the circuit breaker pattern is a way to preventing a failures. Okay, failures in one part of your system from cascading the other parts. Okay, so it works by wrapping a service call in a circuit breaker object, so which monitors the call success or like failures. Okay, so if the calls fails repeatedly, okay, so the circuit breaker trips and opens and preventing the further attempts to call the service until it's safe to do so. So here I'm going to talk about like how the circuit breaker pattern works here. Okay, so here we have a three states. One is closed state, open state and half open state. So if you are speaking about like closed state, right, so in this state the circuit breaker allows the request to pass through to the service here. Okay, so the circuit breaker keeps tracks of the number of failures and successes here. And if you're coming back to like open state, right, so if the number of failures exceeds, okay, so the failure threshold exceeds here. If the number of failures exceeds a predefined threshold, let's say that you define like some predefined threshold here, so the circuit breaker trips and move to the open state here. Okay, and so in this state the circuit breaker immediately fails any request without attempting to call to the service here. Okay, so often returning to a fallback response here. Okay, so this prevents further like strain on failing service and allows to a time to recover basically. Okay, and coming back to like half open state, so half open state basically after like couple of time or like after a certain timeouts the circuit breaker enters into a half open state. So in this state, okay, so in this state, so the circuit breakers allows a limited number of requests to pass through the service as a test. Okay, so if these requests succeeds, okay, the circuit breaker reset back. Okay, so reset back to closed state. Otherwise, if they fail, the circuit breaker returns to the open state. So this is how the circuit breaker pattern will be work. Okay, so the benefits is we can improve the resilience here. So the pattern helps to system to degrade the gracefully by providing a fallback mechanism or like alternative responses when a service is down. And apart from this, better performance as well. So it prevents the resources from being wasted on a calls, okay, that are likely to be failed, so which improve the overall system performance. And apart from this, fast recovery. So by reducing the load on failing service, okay, the circuit breaker allows it to recover faster basically. Okay, so this is the circuit breaker pattern. So I'm going to implement this circuit breaker pattern by using Resilience4J library. Okay, so let's jump into the code. Okay, so now I'm going to implement this circuit breaker pattern here by using Resilience4J library here. Okay, so here in my last videos actually I have explained about Spring Cloud load balancing. So I'm going to make use the same same code here. So here Spring Cloud load balancing, I will explain what it does. So here actually we have a one inventory controller. Okay, so this inventory controller have a one method that is get product details method. So this internally calls by using load balancer web client. So here I am using web client here to communicate with like from one service to another service. Okay, so with the help of this I am calling this product service here. Okay, so this is my product service URL and I am calling this products. Okay, and I'm just returning this. That's it, right? And this web client here actually load balanced here. So I have written like couple of classes here. So this is my inventory configuration class. Okay, here I have defined the instances. Actually I have defined two instances. Okay, one is running on 8081 and another one is 8082. Okay, So this is my inventory configuration and this is my supplier class, and after that, like, this is my web client configuration. Okay, I have load balanced with the help of this @load balanced annotation. Okay, I have defined this load balanced client as well. Okay, so it's straightforward. So I'm going to make use this inventory um, service here. Okay, to implement this circuit breaker here. So basically, if you want to work with this, so first, like, I already started this services. Okay, I ran locally. So let's check this. This is the Eureka server. Here it is registered with this 3 services: product service and Spring Cloud load balancing. This is my inventory service, and this is Jipkin service. Okay, so if you open this, okay, this is my inventory endpoint. If you hit this, you will see the product details because it is internally calling product service here. Okay, now, so to work with this Resilience4J, right, so I need like a couple of dependencies, right? So let's open the pom.xml file here. Okay, here let's add the dependencies. So here actually let's refresh this. We need like 4 dependencies here. One is like Spring Boot Starter AOP dependency, and so this is Resilience4J Spring Boot dependency, and apart from this, I need like Resilience4J reactor. Why we require this dependency is because we are using like Spring Boot WebFlex dependency here. So because we are using like web client, right, so that is the reason I just added this Resilience4J reactor dependency here. Okay, and apart from this, we need an actuator, okay, to check the configuration related to this circuit breaker here. Okay, so once you added this, right, so basically we need like let's controller. So in this controller, basically we need to add like some code here. Okay, so before that, basically we need to define, okay, some of the properties in our application.yaml file here. Okay, okay, so this Resilience4J circuit breaker configs. Okay, here I have provided the default, so if you want, you can provide the service name as well. So registered health indicator true, and so here I have defined like sliding window size and permitted number of calls in half open state. Automatic transition from open to half open is enabled or not. Okay, waiting duration in open state, failure rate threshold, and minimum number of calls, and event consumer buffer size, and sliding window type. Okay, so these are the properties I will explain one by one here. So if you open, so this is the official Resilience4J library page. Okay, I will attach in this video description. You can also go through this. The circuit breaker is implemented via a finite state machine with 3 normal states, as we discussed earlier: closed, open, and half open states here. Okay, so the circuit breaker uses a sliding window to store and aggregate the outcome of the calls. Okay, so you can choose between count based or like time based here. I'm going to explain about the count based. Okay, so here count based sliding window, basically this count based sliding window is implemented with circular array of n measurements. So if the count window size is 10, the circular array has always 10 measurements. Okay, so this sliding window incrementally updates the total aggregation here. Okay, so I will explain as a practically, and apart from this, here they have defined like properties as well, config property, and what is the value and what is the description here. So first we will go through one by one here. Okay, sliding window size is 10 here. So sliding window size is 10 here, so means configure the size of the sliding window, so which is used to record the outcome of the calls when the circuit breaker is closed. Okay, so when the circuit breaker is closed, so it will basically record the outcome of the calls. So here I have defined the 10. Okay, and after that, permitted number of calls in half open state. So permitted calls in the half open state is 3. So this is straightforward. Okay, So we will permit like only 3 calls in the half open state, and so automatic transition from half open state to open state here. Okay, so this is also like automatic transition from open to half open is enabled. Okay, and apart from this, waiting duration in open state. Okay, waiting duration, yeah. So the time that the circuit breaker should be wait before transition from open to half open. So before it is transition from open to half open, so how much time it has to wait? I have just mentioned like 5 seconds here. And failure rate threshold. Okay, so failure rate threshold is 50%. So you can configure the percentage here. So when the failure rate is equal or greater than, okay, the threshold. Okay, so the circuit breaker transition to open and starts short circuiting calls here. Okay, and so minimum number of calls. So how many minimum number of calls it has to be allowed here? So basically it configures the minimum number of calls so which are required here. So before the circuit breaker can calculate the error rate or like slow call rate. Okay, so for example here I have given like 5, right? If minimum number of calls is 5, then at least 5 calls must be recorded here, so before the failure rate can be calculated here. Okay, so even like 4 calls are like have been recorded, the circuit breaker will not transition to open even if 4 calls have failed here. Okay, so like this it will work. And apart from this, event consumer buffer size and sliding window type here. Okay, so sliding window type is count based here. So we have defined like 2 types. One is like count based and the time based here. Okay, so we can configure the sliding window which is used to record the outcome of the calls when the circuit breaker is closed here. Okay, so sliding window can either be count based or time based here. So if the sliding window is count based, right, so the last sliding window size calls are recorded and aggregated here. Okay, so that's it. Once we added this configuration properties, right, so we need like actuator properties as well. Okay, so we need to check out the actuator properties in our health endpoint. Okay, so that is the reason we require that properties. Let's add that. Okay, so management health defaults enabled is true, and circuit breakers, this is management circuit breakers. Okay, we need to enable this one as well. And apart from this, I have added like some of the web exposure and health show details. Okay, so that's it. And what we need to do is we need to add like fallback mechanism in the controller here. Okay, so we have added the dependencies, right? So we have like circuit breaker annotation. So here we can define circuit breaker diff. Okay, so here what I will do is I will provide like inventory service. Okay, and apart from this we have a fallback method. So in the fallback method we have to define the fallback method name. Okay, what I will do is fallback, I will take fallback product details. Okay, and okay, to save the time I already have like this method is implemented already. Okay, so what I'm doing is just added like one fallback product details method. This name should be matched with this name. Okay, and here I just added like fallback list here. So instead of returning actual list here, so you can add like one dummy list, fallback list, and you can return it, or like you can return like empty list as well. Okay, so here I just added fallback product description, something like I have added here. Okay, so when the service is down, product service is down, it has to be written this method and it has to be written this fallback product description instead of actual list. Okay, so that's it, it's straightforward. So let's restart this application. Okay, it is restarted now, and this is our Spring Cloud load balancing or inventory service. And let's hit this inventory endpoint and see. So this is returning successfully this products. Okay, so we have a couple of products. This is returning couple of products here. And now, so this is our actuator health endpoint. Hit this and you will see all the actuator related configurations here. Okay, so here we can see this buffer calls we hit like one time, that is the reason it is showing 1, and after that failed calls, we don't have any failed calls, that is the reason it is showing 0. And state is closed means, so the request is normally flowing to that our service here. Okay, so what I will do is I will make it down this service. Okay, so before that actually we have configured this. Okay, so waiting duration in open state is 5 seconds. Okay, so I will explain what is that. Before that I will make it down this product service. Okay, I'm stopping 2 instances here. Okay, it has been stopped. Now hit this endpoint, you will see this fallback product description here. Okay, so our fallback method is calling. So now let's hit this. You will see the failed calls is 1 here. Okay, so now, so basically this will allow only 5 calls, but so after 5 seconds, right? So what I will do is 1 2 3 4. Okay, I hit 4 times. Okay, it's went to open state. So in open state basically it will wait for only 5 seconds. If you can see here. Okay, after 5 seconds it will transition to half open. Okay, so now let's refresh this. See this, so the state is half open state here, because we have mentioned like 5 seconds in the open state. After 5 seconds automatically it will transition to half open state. Okay, so if you want to see like in the half open state basically it will allow 3 calls, right? So let's hit 3 times. Okay, from half open to it. Okay, switch it to open state here, and again after 5 seconds it will go back to half open state because of this 5 seconds. Okay, so let's see if I want to change this behavior, you can just provide the 100 seconds here. Okay, let's restart this. So we have restarted this, and now hit this and going back to. Okay, so now this is in closed state. Okay, because we have restarted, and so it should permit 5 calls only 5 calls only, right? So I will hit 4 times. Okay, the 5th time when you enter this it will reach to open state, right? So from open state to half open state basically it will take 100 seconds, right? So now even if you hit like after 5 seconds there is no change, right? So now what I will do is I will hit multiple times and I will hit this. Okay, still I can see, okay, open state only. So after like 100 seconds, so it will reach to half open state. Okay, so and after that we have a product service, right? So I will restart the services in the meantime. Okay, I restarted. Let's hit this. Still I think so not started. Let me hit. So why Eureka is not picked? So let me change to localhost. Okay, now it started picking this. Okay, now you can see half open because we have restarted our services. So that is the reason this has been changed from open to half open state. Now hit 3 times, second time and third time. Okay, now coming back here, see this. So it is successful after 3 calls. That is the reason it is switched from half open to closed state, right? So hit this multiple times, you will see, okay, all the buffered calls here, there is no failed calls. So this is how this circuit breaker resilience 4J will work. Okay, so that's it, friend. So if you like this video, please go ahead and like. If you haven't subscribed my YouTube channel, please go ahead and subscribe my YouTube channel.